Welcome and thanks for joining us. My guests today are Frank Lavigne, he's the global leader for data services at Red Hat, and Michael Epley, the chief architect and security strategist at Red Hat. Gentlemen, good to have you with us today.
Thank you for having us.
Thank you.
Now we're going to talk about artificial intelligence and the development of it, the data strategies for it, and I guess it's a good maybe place to start to talk about use cases, because that leads to how you do development and what data you choose. And in your experience with federal agencies so far, why and how are they doing AI? What's their purpose here?
Well, I think the overall picture of artificial intelligence is the idea, there's a lot of fear about how it's going to replace jobs. And I think that fear is largely unfounded. Just the arc of history shows that automation tends to bring about more jobs than it takes away right away. So I think in the short term, there may be some losses, but I think ultimately it's really about augmenting human intelligence. I think that's really where the sweet spot is, that a single human can only have so many things on in their head at the same time or notice certain things, whereas a computer can scale that many, many times. And I think there's a huge opportunity for agencies to leverage that ability.
All right. Michael?
Yeah, I'd agree 100% with that. And in fact, it's the deluge of data, which is the real problem. We have too much work for our humans to do. And that's really where the value of AI comes in, where we can use these tools to automate the process of sifting through that data and pulling out the important bits that we can then draw our attention to for humans or human analysts and decision makers, so they can then make decisions based on a much broader swath of that data, and data that they might not even look at previously because they just didn't have the capacity to do so. So it opens up options rather than closes those down. And yeah, I think as we adopt these kind of products and solutions and AI into these, we'll be able to open up a lot more use cases than we can currently even tackle and even dream of right now. And we're still trying to figure out where can we possibly apply AI. And there's a huge number of use cases that people are just still inventing because there's a huge number of problems that we just couldn't even tackle before that AI now opens up.
And this idea of the deluge of data and the selection of data, in some sense, data becomes the acquired raw material for artificial intelligence. It's a supply chain. And so what are some good strategies for ensuring that the provenance of that data, the applicability of that data, the data in such a way that it won't introduce unwanted results or biases into your algorithmic operations and so forth? You need a data strategy, really, as if it's part of a supply chain. Fair to say?
Absolutely. I mean, one of the phrases that you've heard a lot was that how data was the new oil, and there's a certain amount of that analogy really resonates because in its raw, unrefined state, data like oil really can't do much. It has to go through a process through refinement, and our refinement is called data engineering, and it becomes a product after it's been refined. And to your point, yeah, I mean, when you look at these large language models, they consume mass quantities of information. The old phrase of garbage in, garbage out, I think still applies. If you give it bad data in, or biased data, or tainted data in, you're going to get at the very least, you're going to get subpar results in your end product. At worst, you can get a really biased and ineffective model.
Right, so the work really has to begin at the front end in not just curating, but as you say, engineering the data, and what's involved with that.
Yeah, and I'm glad you mentioned supply chain as well, because if we look at like the cybersecurity aspects of AI, we're just starting to understand what those are. And we've had, this pandemic that's really focused our attention on supply chains and global supply chains from a physical resource perspective. And we've seen how fragile those supply chains are. And on the cybersecurity side of things, we've seen folks that are exploiting the supply chains in our software and our hardware and other information systems. And that's actually the largest growing area of cybersecurity attacks, and fastest growing, is this idea that they can introduce defects into your supply chain, because those supply chains, especially for software, are really not well understood, very complex, especially if we're talking things like open source, that it might have thousands of globally distributed developers working on a particular project and thousands of projects. And these tools are now all getting integrated without really understanding what the potential impacts are of any particular change. And as we consume data, process data, and do all the data management necessary to enable our AI workflows, these supply chains are getting more complex and less understood. And it introduces opportunities for malicious actors to taint that data, maybe intentionally bias our results. And at the same time, we've got obligations when we're using these tools to meet. We have to secure our system so we can have confidence in our decision making that these tools enable. And then we have to meet legal requirements. We have ethical concerns about using AI, health and safety concerns if we're going to enable AI to enable autonomous vehicles, for example. And these things all have to be considered, and the safety of these systems have to be considered. And that's all dependent on that supply chain.
That's really a new angle on cybersecurity. That is, the motivation of people that would get into that data or maybe alter it in some way is not, say, theft of information or taking PII, this kind of thing, but actually influencing the artificial intelligence outcomes, which could be just as insidious as any other motivation for hackers.
Yeah, absolutely. I mean, hackers or any malicious actor is going to be heavily incentivized to taint these tools because they're not well understood how they operate internally. In fact, part of a goal of an AI is to distill a huge body of data into a small model. And that model is going to encode a lot of information and a lot of relationships that aren't understood by humans. That's kind of the whole point about enabling these as tools in our decision chains. And yeah, that's a huge opportunity for an actor. If they can influence those models and how they operate, what that end result and what those decision makers see at the end of the day.
And the influence comes via the data, though, correct?
Well, that is one potential vector. I think one of the things that I think we're going to see as an emerging threat area is data, training data being a vector of attack. Mm-hmm. And it's one of those things where you can't, particularly when you're dealing with generative AI and large language models, they get better as they get more data in to train it. So that attack surface is only going to grow. And I don't think anyone can say with what that looks like right now with any confidence, because these are large, complex systems where the inner workings are largely not obvious to us humans. And I think it's safe to say we don't know quite what we don't know yet, and the unintended consequences are definitely going to show up. And the question is, how do we mitigate that risk today, and how do we better understand that for the future?
Yes, because if you introduce some sort of a bias, then you could actually influence the algorithm to get worse over time.
Absolutely.
As it multiplies the mistakes.
One of the emerging kind of patterns you're seeing, and you'll hear this kind of hyped up, is the idea that the large language models are not getting smarter; they're getting less smart over time, because part of it is that if you start to get a feedback loop, right? And what is that going to look like? As we create information and then we train that the model on not just what humans have said over thousands of years, but what machines are saying or machines are creating, how is that going to impact the model? Is that going to make it better? Is that going to make it worse? Is it going to make it irrelevant? Right? I think it's still too early to call that.
All right, so what are some good strategies for ensuring that you have the right data that's engineered in the right manner as agencies develop AI for applications?
Yeah, I think Frank kind of hinted, we're still trying to figure that out. But in some sense, the basics of cybersecurity, data management are still kind of important here. And I think I heard the word provenance thrown out earlier. And that's one big part of it, understanding where your data is coming from, who's contributing to that data. And the same could be said about all other parts of your supply chain. How you're managing that data through your data management tools, filtering or enhancing that data or cleaning that data is going to all impact that data quality. And then other factors in your supply chain, the tools that you're using, how they are implemented, what biases they might be introducing. And if you're looking at things like the provenance, one of the things that we always want to look at is the confidence of the data and the data set that you have. So how confident are you that in the truthiness of that data? And in real data, there's always uncertainty. And how do we encapsulate or encode that uncertainty in our training and our model, and then carry that through that process so we can relay a certain amount of uncertainty with respect to the results of those AI systems.
And you mentioned earlier Red Hat has a engineering approach to data. It seems like that could be a good control point for making sure that the data is in the manner that you need it to be.
Absolutely. Although I will say that good provenance and good governance is 80% people and 20% technology. But yeah, I mean, starting from the open source foundation, even though there are developers scattered throughout the world, everything is out on the table, and each part can be inspected. Right? There's many eyes on it, and that has it does introduce some level of risk, but I think that's far better than a closed source system where you really have no idea what hands have touched the code. Whereas if it's out in the open, you have a lot more transparency and visibility into what goes into the tools. And all of our engineering at Red Hat is based primarily on open source. And I think that's particularly important for government agencies, that you have full transparency from all the way down to the source code that are creating these large language models, and all of the engineering that goes into it is also based on open source technology. And I think that has two benefits: one, the transparency, and two, the ability to integrate with any system. I think that's what is a key advantage to us, because we don't push anyone into a particularly proprietary direction when engineering their systems.
All right, we're going to get into the whole subject of DevSecOps as applied to AI, but first we're going to take a short break. My guests today are Frank Levinier. He's the global leader for data services at Red Hat. Michael Epley is the chief architect and security strategist at Red Hat. I'm Federal Drive host Tom Temin. This is Federal Insights, sponsored by Red Hat here on Federal News Network. Welcome back to Federal Insights, sponsored by Red Hat here on Federal News Network. My guests today are Frank Levinier. He's the global leader for data services at Red Hat, and Michael Epley, the chief architect and security strategist at Red Hat. And I'm Tom Temin. And let's get into this topic of the regularization, if you will, of development of AI and machine learning applications, because we talked earlier about data management, and let's presume that you have the right data for training and that the right data sources for ongoing operation of what it is you come up with. But you still have to come up with the application. And I guess my question is, does the DevSecOps world offer any lessons for development of ML and AI applications?
I think absolutely. I think one of the shifts that we're seeing is that the first decade of AI, or before we called it AI, was big data, right? Just the sheer engineering challenge of getting all that data, right, and storing it in one place, and making it accessible. Then some very smart people realized, hey, you can distill this down to a model, and basically that was the rise of AI. I think now the question is, well, now that you have a model, and realistically, organizations are probably going to have many, many models. Now it becomes a matter of how do you manage that, right? How do you manage that at scale? And I think that DevSecOps we can learn a lot from there. And in the context of AI, it's called MLOps, or machine learning operations. And some of the characters, or the names of the parts are different. The players are a little bit different, but the story is the same. And if they're not solved problems from DevSecOps, they are very well worked out patterns that will be successful.
Yeah, and I would say that DevOps and DevSecOps, we've got a little bit of a head start because we've thought about these problems in terms of cybersecurity for a while. Is how do we engineer these processes to be reliable, robust, repeatable, and we can use a lot of the same techniques. And the first one is maybe just regularize, understand that we have this process and we can create these tools, and we call these pipelines or DevSecOps frameworks that allow us to convert whatever our input is, and in the case of standard DevSecOps, it's source code, into an application. And we can apply those same techniques and lessons learned from that. Things like integrating in control points or governance points or checkpoints signing and attesting to the different artifacts, as well as things like version and configuration management of our pipelines, as well as the inputs and outputs into that. And I think I'll hit on something that Frank mentioned a second ago. We're going to have lots of these models. And part of that stems from this idea of data governance. We're going to have different types of data useful for different use cases. If we're looking at like the ethical or the restrictions on using kinds of data, like we might have different data that's useful for different purposes or only can be used in certain purposes. For example, we might want to exclude from a certain model PII, because that PII has restricted handling. We don't want that leaking out, or we don't want the model to training inappropriately on that kind of information that then could maybe later discovered or later used against somebody. And so we might have variants of models for different use cases. This one can be used where PII is restricted, and this one might be available for research communities where they have special or privileged access to that particular kind of data. And we're going to have to understand and track that data, as well as be able to redo those models or train those models differently when we get new data in, and make sure that those models remain separate in that supply chain.
Yeah, there's an old-time cartoon in software development that shows the variance between what a user actually wanted and what developers came up with and how it was engineered and installed. You've seen that. It's like a 9-panel cartoon.
Yeah.
It's all over the internet. But it strikes me that the important component in DevSecOps, which is often overlooked or maybe assumed, is user involvement, because when you talk about ML and AI applications to augment human intelligence, without the humans actually on the line whose intelligence is to be augmented, you could come up with all kinds of wild things. So how do you ensure that what it is that the augmentation produces gets baked into what is actually developed in these operations, in these DevSecOps types of pipelines for AI and ML?
I think it comes down to planning. I think there's no substitute for good engineering. We can slap all the AI we want together, but unless you have a good plan and a good execution of said plan, you can't use AI to get away from good, solid engineering foundations.
Because there's also the issue of the authority to operate, which is related here, because yes, I really want this thing. It's going to help me do my job. It's going to help my adjudicators get through their caseloads quicker. It's going to, again, a million possible use cases. But without ATO, you have a big risk in the federal government of trying to deploy that software. So how do you make sure that the inherited qualities of maybe older applications also come into this?
Yeah, I would say that's another place where like our learning experience through DevSecOps and I'll call it continuous ATO processes, which are still actively being developed, are illustrative though, right? So we've learned to wire up our pipelines, for example, with the processes necessary to collect the evidence that we need to provide our ATO and part of that package for getting accreditation. And we can do the same thing for our data and MLOps pipelines. Where's that data coming from? What's the provenance? What are the confidence intervals on that data? What are the processes we put into place in that pipeline to validate the models that we're generating, or ensure or protect from data leaks or data that were not being used? What sort of tests have we run on that model to validate, again, that model actually makes sense? And that's, again, where these are going to be decision augmentation tools. We're still going to have humans in the loop that are providing their subject matter expertise to validate those models and to test and develop, and to Frank's comment, the engineering necessary to actually produce that whole pipeline and provide that confidence at the end of the day.
And all of those controls and all of those considerations you mentioned seem to imply that the actual coding is the minor part of the whole DevSecOps, but it takes a team. Data people, application people, end users, program managers. Tell us how you get a DevSecOps operation for AI/ML such that all those considerations and the people they represent are involved here.
I think that part of the reason why that cartoon you mentioned was so funny is because there's a lot of assumptions are made in the design process. And I think that the less assumptions that you make and you kind of narrow down exactly what you want to build, how you want to build it, you can avoid a lot of that. some measure of drift, as it were, is unavoidable, but you can minimize that to the max. Minimize it to the max. But I mean, minimize it as best you can by just good planning and good engineering, good policies, good procedures, and make sure you follow them, and change them if they don't make sense. This ML ops is still very much an emerging field, so I think no one really has all the answers yet. But I think certainly with Red Hat, we have a lot of experience with bringing to market source code from very disparate sources and tracking that and managing that. So I think that's something that the open source communities at large can really help with that. But this is something that I think data scientists, AI engineers are starting to warm up to. The idea that they are now, their products are no longer experimental, right? They have to go into production. And there's a very different standard of engineering for research and development than there is for production and mass deployment. And I think that data scientists are finally realizing that, our work is no longer, experimental or fringe. It is the cornerstone of what the of any enterprise is going to be like, now, arguably now, but definitely in the near future.
And you mentioned that idea of drift, and that's the big difference, one of the big differences between AI ML applications and other applications. If you designed logic in legacy code, it'll do the same thing
right,
absolutely repeatably for 50 years. And in fact, in the government, sometimes it is doing the same thing for 50 years. But the very goal of AI and ML is that the machine adapts over time.
Right.
You want it to adapt in the right way. So maybe explain some of the best strategies for avoiding drift that's going the wrong way.
So I think drift is unavoidable. And I think part of it is a lot of it depends on exactly what type of AI and model you're building, right? So if you're trying to predict the future, I think we can all say that predicting the future is hard. And so weather reports I think are a good analogy, right? If I look at the 10-day forecast, day one's forecast is going to be very accurate, right? Day 10, not so much. That's because there's so many things playing into it. And expecting models that were trained, today to be any model, whether it's weather or whether you're predicting financial markets, anything, expecting that to be accurate 10 years from now or 50 years from now, as it is, this week or next month, is not a realistic expectation. So drift is one of those things where part of the ML ops pipeline is you go back and you retrain, right? So where did the model go wrong, right? Where are there new factors at play that you have to take into account, and then you retrain it. Retraining is I think going to be, it's analogous to bugs, right? So software, bugs happen, right? Sometimes requirements change. So the loop is already there, like the pattern of the loop of going back, redoing it, redeploying, and then repeating that is something that is a big part of DevSecOps, and it's it's a similar story with MLOps.
Okay, final 15 seconds, Michael.
Well, I'm glad he brought it back to that because that's the agile workflow, is like the constant repeat. And going back to something earlier that we talked about, is the idea that we want to manage the data going in. In some cases, models regress. And why do we regress? Well, sometimes they're ingesting previously produced AI outputs and model outputs. And we have to, again, implement good governance in engineering into our processes to remove that data or call that data and manage that. That's what our attention to that kind of engineering process is going to do for us.
Okay, well, good ways to know not how to regress, but to keep progressing in your AI ML journey. Let me thank today's guests. Frank Lavignier is the global leader for data services at Red Hat. Michael Epley, the chief architect and security strategist at Red Hat. Thanks so much.
Thank you very much for having us.
Yeah, thank you.
I'm Federal Drive host Tom Temin. You're listening to Federal News Network. For more on this discussion, please visit federalnewsnetwork.com and search Red Hat.